Thank you very much. So I will just dive into the context of the reason why we should care about commercialization of carbon mineralization project. And I will focus on the in situ approach. So as Kauri told you this morning, all these injections taking place underground for permanent storage. And here you have a logarithmic scale. So it goes from 0.001 gigatons of CO2, which is actually 1 million tons of CO2, mind-blowing, all the way to 1 million gigatons of CO2. I'm specifying that it's logarithmic scale because it's important to understand that each increment is adding a 0 to this number. So we go from 1 to 10, 100, and 1,000, as shown over here. And it's important because when I will say that this number changes an order of magnitude, you will understand that this is a big jump. You know, if I'm giving you 10 euros, it's not the same if I'm giving you 100 euros. That's a quick way to see it. So if now we focus on the theoretical potential of the main rocks for in situ carbon mineralization, we see that we have basalts and peridotite. Basalts can be considered on land or offshore, so in submarine environment, and peridotite mostly on land. So we don't need to go into the details of these rocks, but what is important to understand is that the total theoretical storage potential of these rocks goes from 62,000 to almost 1 million gigatons of CO2. So it's enormous. And if now we compare it to what proposed by the Clean Air Task Force, analyzing all the IPCC pathways for the 1.5 degree scenarios, we see that CCS should be responsible of 665 gigatons of CO2 by 2100 as a cumulative number. And as I said, this is orders of magnitude lower than the theoretical potential of these rocks. And I'm also introducing a temporal aspect to this number, by 2100, like something far away in the future. And I think it's important to contextualize to something that we can really understand. And for this reason, I took the number from the Global CCS Institute, where the current CCS capacity is estimated to be 0.05 gigatons per year. Again, way lower in terms of scale. And to point out that right now, carbon mineralization is not even on this scale, it's much below. But we want to put our fingerprints on this scale with the first million-ton project with the Coda terminal. And if we take the current CCS capacity and we estimated how much will be by 2100, we reach 3.7 gigatons, so way below the target put by the IPCC. This means that we need to scale up, and on average will be 8.5 gigatons of CO2 per year. This morning you heard a different number, was up to 10 gigatons of CO2 by 2050. Nobody's lying, we are all correct. We are just using different calculations. So we can say that on average, linearly, we will need 8.5 gigatons of CO2 per year, and keep this number in mind for the next slide. In this case, I wanted to put into the context of the market. On the y-axis, you have the cost per ton of CO2 injected, and on the x-axis, the reaction of the reaction time and the reservoir capacity of the rocks previously shown. Because these rocks can be all available, we spoke about their potential, but it takes a while to cook them and bond the CO2. So this time is shown on the x-axis. Both on logarithmic scale, you know all about it, so we can just cruise through. Amongst all the materials shown on this plot, we can focus on the in situ rocks. So I circle them with the black box, like what we said before, on-land basalt, offshore basalt, and peridotite. And the on-land in situ rocks are the one at the bottom, and we are going to focus on them. And so to estimate the market for in situ on-land storage, we have estimated costs that vary from $10 to $30 per ton of CO2 injected. We have a capacity of these rocks that goes from 0.01 to 40 gigatons of CO2 per year. And this means that the carbon mineralization has got the potential to contribute significantly to this average 8.5 CO2 per year. And also, it means that for this challenge, carbon mineralization requires a capital input or an investment that could go from $85 to $255 billion per year. And I think it's important when we speak about investment to have also the size of the market we are talking about. So, what do we actually need to know to develop on a commercial scale mineralization project and at scale? What I will do next is to show you different slides with the main aspect that at Carbfix we think will have to be assessed to develop a commercial project. So first of all, we want to know the location and the characteristic of suitable reservoirs. We have global estimates coming a bit from all the main institutions around the world. Here I'll put some examples. What we need are way more precise and localized data to really understand what of that theoretical potential is available for commercial projects. So we need to know, for example, volume, depth, and storage capacity. We need to know the water availability, which is a critical resource in this technology. And we need to know the accessibility to this reservoir, and we need to know the distance from the most suitable markets. And in these terms, we also need to know the CO2 source. We classify it as a point source or as a point-to-point. Point source could be emitters on the same site, or could also be direct air capture unit on the site of the reservoir. And here is indicated in the pathway A and C. Point-to-point are all these emitters that are not located where the reservoir is, but somewhere else. So this will require the transport to a hub in the injection into the reservoir, in the pathway B. So even if Carbfix is agnostic of where the CO2 comes from, we have all these different scenarios, we still need to comply to local regulation. So we need to define a certain level of purity and have a complete understanding of the composition of these gases coming to the reservoir. The third aspect to consider is a partner. We classify them as a business partner or as a strategic partner. Business partner are all those emitters within the hard-to-abate sector, so cement, aluminum, steel, and chemicals. And I've put a map as example for all the steel plants, or most of the steel plants in Europe. We target the geothermal industry, emitter with strong commitments to net zero targets, project developer, investment firm, DAX, and BEX company. So Carbfix really wants to develop these commercial projects with business partner along the way. But we cannot do it without even strategic partner, and this strategic partner can be coming from all across the value chain. Carbfix is focusing on the storage, but without the rest of the players, we will not be able to deliver commercial project at scale. So strategic partner can include specialist work from other sectors, academia, and EPC business people. Another aspect to consider when we want to develop a commercial project is resources and infrastructure. In this case, I put two examples where you see at the bottom left the map from the Global Energy Monitor showing all the existing pipelines and existing LNG terminals that could potentially be reused for carbon mineralization projects. And on the right side, the CCUS map showing the location of the Class 6 wells in North America. And you heard a bit before this name of Class 6 wells, which is what currently is envisaged by the EPA in the US for carbon mineralization injection. A final aspect that is actually including several, but since they are so interconnected, I thought of presenting them together, is policy, regulations, and markets. We cannot develop a project, we cannot present it to a business partner if we don't know the policy in a specific country, if we don't know the policies across countries, and if we don't know the local regulations. So in the map, you have an example of a policy indicator database from the Global CCS Institute showing the scoring, let's say, of the policy development across the world. And this is important both to track the progress over time and also to highlight the opportunities to drive long-term investment. So when we present the project, we will be able to say, okay, the policy is developing into the right direction. We can mitigate the risk in these different ways. In terms of local regulations, we need to know more specifically permits and licensing procedures, the timing, the regulatory bodies. We need to know the classification of CO2 charged water injections and also the requirements for the dedicated wells. So in terms of market, we want to also understand the carbon pricing, so compliance versus crediting. And even just an example of the compliance market is this map showing the price around the world, and it varies from 0.6 US dollars per ton of CO2 equivalent to 167, with the 0.6 being in Indonesia and 167 being in Uruguay, just to give you, a spectrum of differences. So what we did at Carbfix is to establish a pathway to create value while trying to develop commercial activities. And we have this pathway divided in 3 different phases. We have the preparation with the different studies, and I'm talking a bit about this later. We have the design, construction, and commission phase to develop pilot and commercial injections. And then we have the last longi, license fee and IP phase, where we think the operations will take place on a long term. So we envisage the first part to take from 12 to 18 months, the second from 24 to 42 months, and the operations are expected to last 30 years. And if we go more into the details of the commercial studies, we see that our aim is to reach a commercial pilot. We want to understand more about the subsurface, and to do that, we want to target the most suitable sites, mitigating the risk. And we want to mitigate this risk with this stepwise approach, going from the L1 study, the level 1, where we'll theoretically look at all the data available. We will highlight the knowledge gaps and the preliminary storage capacity. We will pass to an L2 study with the pre-feasibility. We are going to go into the lab with the rocks, and we are got characterization. And the L3 feasibility study, where the techno-economic assessment will take place, along with the preliminary injection strategy. Here is a map of the commercial activities of Carbfix to date. As you can see, we are a bit all over the world, covering 21 countries. And I want to end my presentation starting to introduce the future speakers presenting their international mineralization projects. So we have Sean O'Connor from Deep Sky Climate for a project in Quebec. We should have Todd Malan from Talon for the Minnesota project Tamarack. We don't have our Todd, we got an our Todd. We got Todd Sharp from the PNNL speaking about various mineralization projects. We have Claire Nelson from Sella speaking about the project in Kenya. Vikram Vishal from the Indian Institute of Technology in Bombay speaking about the exciting potential of the Deccan Traps. We have Joanna Vieira Duarte from Neustark speaking about the collaboration between Iceland and Switzerland. And then we have Tofek Dansey from the Council for Geoscience in South Africa. Thank you very much.